Hello everyone, and welcome to a video in which we are going to try to do a completely online lab to start our new unit. Now last unit we looked at projectile motion, a specific case of two-dimensional motion, and we're going to look at another special case of two-dimensional motion in this unit. It's the motion that you will see of the bucket in the video. So notice, the bucket is going in a particular shape, right? And there's something also special about that motion. Let me replay it for you again. Notice that the bucket is moving in a circle. And as close as I can make it, the speed is constant. Not the velocity, being very specific, but the speed is constant. And that's the kind of motion we're going to look at in this unit. That's something moving in a circle at constant speed. So our next question then is, what things do you think I could have changed about my little demo there that would have affected how fast the bucket moved? Well, I could have changed perhaps the length of the string. And the length of the string is, of course, the radius of the circle that the bucket was moving in. Maybe I could have poured some water in the bucket. I'll do that later on in the unit. Right, and changed its mass. And I certainly could have pulled harder or not as hard on the string, which is the amount of force acting on the bucket. So this is kind of a big lab, actually. It's a 4-variable lab, right? We'll have 3 independent and 1 dependent variables. And that means that we're going to have to do 3 different experiments, right? So we only change one thing at a time. And then we'll shove it all together in the post lab. So the purpose of this lab is to create graphical and mathematical representations of the relationship between the force, the radius, the mass, and the speed for something moving in a circle at a constant speed. Now there is a lab sheet for this, of course, right on the website that you can either print off or just kind of look at and write on separate paper, either way. And you'll notice that there's 3 parts to it. Right? So how are we going to measure all these things? Well, we're actually going to use a simulation that will measure these things for us. But just to kind of get to how the simulation works, the first one let's talk about a bit is speed. Now, it's a constant speed. And because it's a constant speed, we can just break it down to the very generic distance over time. Now, since it's moving in a circle, the distance it moves in, if you think about it going around once, right, going around a circle once, what is that? That's right. That is the circumference of the circle. The time to go around once has a special name. It's not just any random time, it's the time for one complete motion. In physics, we call this the period. It's denoted in an equation by a capital T. So lowercase t is just generic time. Capital T is the time for one complete cycle. This often comes up in things that repeat their motion, like something moving in a circle. Now, if you remember, of course, from the very, very beginning of this year, we figured out an equation for the circumference of a circle. It's 2 pi r, right? Or pi times the diameter, right? But 2 pi times the radius divided by the period. This is a very common little equation to use in this unit of objects moving in circles at constant speeds because it allows us to kind of convert from things that are easier to measure, the radius of the circle and the time it takes to go around once, to the actual speed. We can't just throw a motion detector on it, or we don't have a special cart, that we can use to measure these things. So got to be a little more crafty in how we do this. And in fact, this is what's happening behind the scenes of the simulation. Now, the simulation we're going to use is on the Concept Builder Guy's website. There's a link for it right on my website. So if we go there, here it is. As usual, you just open it up to make it big. You'll notice that there's 3 sliders down here. A speed slider lets you increase and decrease the speed. A radius slider, look at the ball here, right? Increases, decreases the radius. And a mass increases, decreases the mass, right, of the ball. It's my bucket, if you will. You'll also notice that up here, it tells you the force that needs to be exerted to keep these things happening. So notice these are our independent variables because we can control them, and our net force will be the dependent variable. Don't worry about the acceleration right now. We'll get to that in several days from now. Okay, so if you hit start with wherever you have these three set, notice it moves in a circle at a constant speed. And it tells you the force that acts. Change these variables, right? Changes the motion, changes the force. Right? So we can set these at different places. Now, of course, we only want to change one of them at a time so that we can see what effect it has on the motion. There's also these buttons over here which turn on velocity and acceleration arrows. You'll get to those at the last part of the lab, right? If you're working on the lab sheet. And by the way, you can always reset it, right, to get rid of all the dots. So you can move these around if you want a clean thing here, right? And you hit start, right? And that'll give you a nice clean look at it. Okay? So this is a simulation, pretty straightforward. We actually use this in class even if we're in class because it's really hard to control this lab and control all four things and be able to measure three. It gets a little hard. So that's how we're going to use the simulation. Now, it is going to take some graphing, right? Since our speed is independent, we can control it with the slider. The radius is independent and the mass is independent and the force is dependent. In each part of the lab, you're going to have a graph of force on the vertical axis and one of the other variables on the horizontal. It'll be force versus something. Okay? Now you might say, well, how are we going to graph? Well, you could do it by hand, but to make things easier, I've actually put a link on the website for you to be able to download graphical analysis. Okay, the very program we've been using all year long to make graphs. And it's free. You can download it on any platform, any computer you have, any type of computer. You can even do this on your phone if you want to. And it'll look just like what we've been using in class all along to graph. I've also put on the website the sheet that is the help sheet that usually just lives next to your computer. Well, now you can have that too, right? So you can see how to do the graphs and how to linearize and all of that good stuff is right on that sheet. And you can do it right in the same program. So my hope is here that you can use this simulation to do the three parts of the lab, right? Answer all the questions. And then next time I will post a post-lab, right, where we'll go over what you hopefully saw and how we can put all three parts together, right, into one math model that relates all four of these variables for objects moving in a circle at constant speed. By the way, there's also a key. So if you're having a little trouble or you want to make sure you're doing things right, you can always check the key as well. So good luck. Hope this all works out for you. Let me know if it doesn't. Office hours, of course, on Wednesday from 3 to 4. Be safe.